Hello, it's Keith here, and this is lesson 2 of the platform-specific series of my Mips assembly programming tutorials. And today what we're going to be looking at the PlayStation, and we're going to be looking at how to read in from one of the joypads. Now, the example we've got today, if I just move this out of the way and move the screen over here, is what this is doing is it's reading in from the joypad and it's showing the raw data to the screen. Now there's actually two ways that we can do this. The first one is the easiest, and this is to ask the BIOS to do the job of reading in from the joypad for us. Now that's a fine way of doing things. In general though, in my tutorials I've often preferred to go directly to the hardware. Becoming hard these days with the 32-bit systems. It was much easier with the 8-bit ones, but we can still actually go straight to the hardware and read in from the joypad on this system. So we will be doing both today. We'll be trying out both, although I guess generally I'd recommend using the BIOS. It does it fine, and as I say, these days with these more advanced systems, avoiding use of the BIOS is not really so credible. Now, one limitation I do have to say is I have been completely unsuccessful in reading from the second joypad, and I think that this is a limitation. I think this is a limitation of the emulator. The emulator apparently claims to support 2 joypads, but I couldn't get the second one to work, and I did see some other people making similar comments online. So either it's my setup or I'm misunderstanding the emulator options. I don't know. I couldn't get the second joypad to work, even though the BIOS calls were supposed to be reading them from both, and the second one just never did anything. So I don't know there. Anyway, let's go over to the source code and let's check out today's example. So this is the example today we're looking at, PSX joystick example. I've used the word joystick there instead of joypad. They're of course basically the same thing. And at the start of our code here, we've got 2 jumps here. One to the hardware direct function and one to the use BIOS function, and these are the 2 alternate examples that we've got. And the first one we're going to look at is the use BIOS one, the easier one of the 2. Now I'll just point out we have some memory defined here, joy data. This is being allocated as part of the free memory, so this is just a pointer to some memory that we're going to use for our joystick functions. The BIOS is basically going to be called, it's going to be passed the pointer to this memory area, and then it's going to basically use that to write the data. Now, when it comes to using the BIOS, we're basically going to jump to some BIOS functions, and these are at memory address B0. So what we're doing here is we're loading the immediate B0 into T0 in register T0 here, and we're going to jump to T0 to execute that call. Now, if you're doing things in C++, things like that, which I never do with these tutorials, these are purely assembly tutorials, but in the documentation you may see functions called things like initpad, and these will probably have some kind of function call like 12H there, 12 in hexadecimal, 12 in hexadecimal there, and then there will be 4 parameters. Now this is how we would call it in something like C. However, we're not using C, we're using assembly, and so things basically go a little bit differently. Firstly, we load T0 with B0. That is a standard thing. That's because we are using the BIOS call there, and so that is what we load in there. We then load T1 with the function number. Now initpad is function 12, and so we're loading 12 in hexadecimal into T1 there. That is the function that we want to call. So 12 is effectively the initpad function of the BIOS. So that's what we're going in there. And then we've got our 4 parameters here, and we load these into the A0 to A3 parameters here. So buffer 1 is going to be joy data. Size 1 is going to be 22 in hexadecimal. Buffer 2 is going to be joy data plus hexadecimal 30, so we're allocating some space there for the first joystick, and then that's basically the second joystick in theory, although I say in practice I couldn't get it to do anything, which is a bit of a shame. Anyway, that's the 4 parameters we're passing to this function, and that JALR there is effectively the same as calling initpad in C++, and so that's setting up the joypad functions and passing the parameters that we're going to be using, basically the addresses that we want it to store its data. We then want to run function 13, which is startpad. Now this takes no parameters, you can see there, and so we're just loading T0 again with B0, and then T1 with function 13 in hexadecimal there, and then we're just calling that. It doesn't matter what A0 to A3 contain, this function doesn't use them. Okay, so that has now basically set up the destination memory address and started polling the joypad, and from this point the BIOS is doing all of the work automatically for us. So all we need to do now to read in from our joypad is just read in from the Joy data memory address that we specified up here, and that will effectively do all the work for us. Now we're going to show the data in two forms here. We're using my memdump function here to show the raw data, 12 lines of raw data from this memory address to screen, so we can see what's in the memory. But also as a test, I'm basically loading in the three 32-bit words here from that memory address there into A0, A1 and A2, which is more practically how you might want to use this, the Joypad. Okay, so let's just fire this up here and let's see what we get on the screen. Okay, so here is the running program, and so this basically is the memory dump here. So these values here are the first Joypad, and then these ones here should be the second. As I say, couldn't get anything to work in it. I'm not really very familiar with this emulator. No cache PSX. I've only used it for these tutorials, and so I didn't want to start playing around trying to figure out whether it worked in other real games. I had spent so long trying to get it working, I kind of gave up, to be honest. So but basically, if we use our up, down, left and right, you can see that those directions are being pressed there. And then if I use the fire buttons here, you can see these are being represented as well. And we've got the analog X and Y there. I don't know if they're actually mapped to anything. I think they will work, but I don't have an analog Joypad plugged in at the moment, so I'm not going to be able to test them. But basically, that is the output there. And we're also showing that in A0 there, and we're loading into A1 and A2. I don't think A2 will ever do anything. A1 is the analogs there. But you can see there that we've got the data being shown to the screen. Very nice. So that's the easiest way of doing things. And as I say, generally speaking, that's the way I would probably recommend. But just for completeness, and because basically it was relatively easy to do. Sometimes it's impossible nowadays with these more advanced systems, but on this one it was relatively easy to read in from the hardware directly. Now basically, if we're going to read in directly, we have a series of ports that we need to use. Now they've got these long addresses here, but we've got Joy Data, Joy Stat, Joy Mode, Joy Control and Joy Board. Now what we first want to do is we want to basically reset things. So basically what we're going to do is we're going to load in the register T1 with the address of Joy Data, and that's going to be the port that we send our data to. We're then going to use this as an offset for the other ports, because all of the other ports come after Joy Data. So we'll use an offset of A to get to the Joy Control port here, and E for the joystick board port here, and 8 for the mode, and so on. So we're going to use that. Now what we're basically going to do is we're going to use some simple functions to help us out. Now we've got a few simple delays here. So we've got this do pause, which is just a very crude delay here, and then the other one we've got is Joy Wait. Now Joy Wait will basically read in from the status port here, and it will test the bit 1 here, and it will wait until this bit turns to 1, which implies that there's some data waiting. So that is waiting for a reply from our sent data. So that we'll be using that as well. Now the first thing we're doing here is we are basically writing a value of 0 to the control port here just to reset things. We've got a simple delay there to just wait for that, and then what we're going to do is we're going to set up the baud rate here. We're going to set the mode, we set that to D here. And then what we need to do next is we need to select the port that we want to use. Now we basically use this combination of bits here for Joypad 1, or a 1-bit set there for Joypad 2, which, as I say, I couldn't get working. And then we store that to the port here, and port A here, the Joy Control port. And again, we've got a simple delay there. Now what we're going to do next is we are going to basically send a sequence of commands, and these are going to initialize the joystick and then read back the resulting data. Now we're using this monitor joy function here, and if we just have a look at what that does, what this is doing is it's loading a byte from the data port, and it's loading 32 bits from the stat port, and the stat port will be shown in A1, and that will be showing a lot of sort of very chaotic data. There's I think there's basically some timers in there, but it was just so that we I use this during my writing and testing this code to make sure that the data coming back was valid and just see what was going on. So here you can see the raw data being outputted, and basically if I press up here, you can see That bit there is changing down, left, right, and then the 4 fires here. So you can see that the bytes being read back are indeed representing the joystick data here, and it is indeed working. Now A1 here, as I say, these are the status port after each of the reads, so very chaotic indeed. These are constantly changing. I think, as I say, there's some kind of timer. But they aren't a problem for us. We wouldn't want to show those, really wouldn't want to do anything with them, but as I say, for debugging purposes it was very helpful to be able to see what was coming back and to see indeed valid data was coming back. So our first command is the value 1. We write the 32-bit word with the value 1 into the data port here, and then we wait for a reply. Now that isn't actually very useful to us. We then write the value 42 and we again wait for the reply, and then after that the following bytes of data are all going to be the buttons and directions for the joystick. Now each time we just write the value 0 to the data port and we wait for the reply. Now we're showing all of these to the screen, but these are the actual ones that contain the various directions and analogs of our joystick. Now at the end of this sequence of reading in all of these bytes, basically I'm running the CLS routine which moves the cursor back to the top, and then we're just repeating indefinitely here. So in this case, unlike the other one, in the last case the joystick was being read in automatically by the BIOS. In this case, the opposite is the case. We're basically having to do the work ourselves. We're having to initialize the port, read in from the port, and configure the port, tell it to send its data, and then read in each of the bytes of data manually. I can say in most cases I don't think this is beneficial, but as an experiment and as a bit of a practice with some Mips programming, it's perfectly good. Now if you like what you've seen, please like and subscribe, because next time we're going to look at a simple example of moving a sprite around the screen using the Joypad. Now this is something I do on all of my tutorials, again probably more useful on the Z80 and 8-bit systems, but I like to do a consistent thing on all of the tutorials, so we're going to do this on the PlayStation as well. So in addition to liking and subscribing, if you want to support my content, you might consider buying my book, Learn Multiplatform Assembly with ChibiAkumas. I have 2 books, one covers Z80, 6502, 68086 and ARM, and the other covers a whole bunch of other things which I can't initially remember. That would be ARM Thumb, 65816, PDP-11, RISC-V, and 6809. So if those sound interesting to you, please check those books out. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.